Hello, everyone.
Hello.
Hello.
Hi.
Please, I want to hear more voices. I want to know that we are
Hello.
active.
Active.
Hello.
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 Hello. Active.
Yeah. Yeah. Thank you, guys. So, you're all welcome to week 1 of the Machine Learning Fundamentals Bootcamp. But before we begin, we have to pray. So, let's pray. Father, in the name of Jesus, we thank you for such a wonderful day. And we thank you for this initiative. We commit it into your hands and we pray that may you guide us, may you teach us, may you bring your Holy Spirit to help us, and may this section be a successful one. Amen.
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 Okay. So we're all welcome. If you are here, then I'm sure you received the email of your selection to participate in this event. And today we'll be talking about the foundations of Python for data science. And our speaker is Mr. Kobo Moses Kwame.
Yeah, hello.
I hope you guys can hear. Yeah.
Yes, we can
Yes,
hear you.
Mr.
Good evening.
Moses, you're welcome. Good
Thank you
evening.
very much for having me here.
Yeah. Please take over.
All right, thank you very much, Nana Abena, for coming. Okay. All right, please give me a minute as I. All right, please, good evening once again. Please, can you all see my screen?
Good evening. Moses, please,
Yes.
I think you have to click your slideshow for it to.
Yes, yes. I wanted to show my face first, but I don't
Okay,
know.
okay. You are free to do so. You are free.
Okay, don't worry. Okay, my name is Moses Kwame, and I'll be your speaker tonight. All right, so I'm actually one of the teaching assistants of the at the University of Ghana, specifically at the Department of Statistics and Natural Science. Okay, please, can you all hear me?
Yes.
Okay,
Yes, please, you can
so
be heard.
all right, sure, thank you very much. All right, so today I'll be taking you through an introduction course, of course, and it's going to be on machine learning and then Python for data science. Okay. Um, our tutor Our section here is going to be in 4 sections, okay? And the 4 sections we'll be talking about: 1, the introduction to machine learning and its concepts; 2, we'll talk about Python for data science. So we are going to have an introduction of Python basics in terms of reusing their libraries, its libraries, such as NumPy, Pandas, Matplotlib, and then what, Seaborn. Then we'll now move on to my VS Code, which is my environment, where I will show you some examples or some practical ways that we will be using in machine learning. Then 4 will be an overview of whatever that we have captured today. I hope you are ready. Hello, I hope we are all ready.
Yes, we are active.
Okay, thank you very much. All right, so we're going to start with introduction to machine learning. What is machine learning? Machine learning is actually a subset of artificial intelligence, what we usually say AI, that enables systems to learn and improve from what experience without being explicitly what programmed. Now, what I mean is that instead of us writing fixed rules, we could provide data and algorithms, okay, and the system would discover patterns and relationship on its own. So that's what machine learning is all about, okay. We don't really have to do much work, but we just have to give a system or have to give a system some set of data and algorithms, okay? And then it's going to help us to come up with nice patterns and then develop some relationships on the data that we are going to give to it. Now, why are we talking about Python and then talking about machine learning? Well, the reason why we are going to use Python mostly with machine learning is that it's a very versatile and popular programming language. Okay, that is, I would say, that helps in simplifying the process of what of building machine learning models. Now, because of this, Python has become one of the most widely used programming languages in data science and machine learning. Okay, and then this presentation is actually going to cover, as I've already mentioned, the concepts and key techniques to get started with what machine learning. We are going to, I've already given the definition, so we are going to talk about the types or the kinds of machine learning concepts that we have. Mainly, we have supervised learning, unsupervised learning, and then reinforced learning. But with the introduction course, we are really going to talk about the supervised learning and then what? The unsupervised machine learning. Now, understanding these definitions is going to help us to select the right approach for solving different problems effectively. Now, let's take them one after the other and then understand what they actually mean. For supervised learning, it has to do with a machine learning a concept that learns from labeled data, where both inputs and then the desired outputs are known. So, for example, let me talk about the diagram on my right. This has to do with, let's say, okay, let me not talk about that. Let me just talk in general. Assume that I want to be able to, let's say, predict, the GPAs of some students. I'm going to need some variables from them. Preferably, I'll be talking about their study hours, their leisure times, what they do. There'll be so many variables from them. Okay. And then with machine learning, talking about supervised learning, I'm going to put their data, okay, and then their GPUs, which are going to be the responses. I'm going to put it in a machine learning algorithm, and this machine learning algorithm is going to learn from it, okay. And at the end of the day, it's going to help me to predict if I give it a new set of students, okay. So some common tasks that supervised learning can do or is able to help us in achieving. One is what is classification. Two is regression, as I just gave you, as I just talked about. And then some examples that we are going to look at is spam detection and then credit card fraud detection, which means that if we have a lot of data that is able to tell us that, oh, if somebody sends an email and then the email has certain attributes, is going to be classified as spam or not as spam. Okay, and in that similar context, we are going to also have a set of data that when we give it to an algorithm, is going to help us to determine whether the transaction that went through is fraudulent or legitimate. Now, typical models that we will be looking at, as I said, is just an introduction course, so I wouldn't go deep into what they actually meant. So typical models that we'll be looking at are linear and logistic regression. We'll be looking at k-nearest neighbors, addition tree and random forest, SVM, and neural networks. These topics will be treated in the upcoming sections, okay? Now, talking about unsupervised learning, as we learned that with supervised learning, it has to do with labeled what? Data. With unsupervised learning, we put unlabeled data, okay, into the algorithm. So unsupervised learning works with unlabeled data. The goal is to discover hidden patterns or structure without knowing the output in advance. So as I talk about the regression example, we might, if I have a student, let's say a student with a GPA of let's say 3.6 or 3.56, that student is going to have certain attributes, okay? So in that course, the supervised learning is going to help us to, he's going to understand the attributes of that student and then bring out the output, which being what? The GPA, okay? But here with unsupervised learning, it doesn't know the outputs, doesn't know, we are not going to give it the outputs for it to know what the student GPA is, although we are going to give it the study hours, the hobby, and all other attributes without what? The outputs. And it's going to still understand, learn, and then give us what? Some patterns. Okay. Now the common task done here has to do with what? Clustering and what? Anomaly what? Detection. An example that this model comes up, learning comes up with is finding themes in blog posts, customer segmentation, that's grouping customers by preferences or by location or by purchasing habits, those things. Then anomaly detection is what? Identifying unusual website traffic patterns. These are some few examples under supervised learning. Now, the typical models that you will be introduced to in the coming sections will be K-means clustering, hierarchical clustering, we have DBS scan, we have PCA, and then auto encoders. You'll be introduced to this in the upcoming. Now, let's look at the differences between supervised and then unsupervised machine learning. With the definition, as we have already seen, that with supervised machine learning, it learns from labeled what? Data, inputs with known outputs. We input data, we give it what? A known output. But with unsupervised machine learning, it learns from what? Unlabeled what? Data, no known outputs. Okay. Now, the goal of a supervised machine learning algorithm or model is to predict outcomes or classify what? Data. For that of unsupervised machine learning is to discover hidden patterns or structures. As I said, the output of supervised machine learning is known target what? Variable. But for unsupervised machine learning is what? There's no predefined target what? Variable. Talking about human intervention, okay, as we can see, for supervised machine learning, it requires labeled training data. Okay, and then for unsupervised machine learning, no labeled training words, no labeled data is required. Okay, all right. So basically, these are some of the differences between supervised machine learning and then what's unsupervised machine learning. As we have first seen from the above slides, if you want to check accuracy evaluation, that is after you are done with your model implementation, which we'll be talking about here, but in the coming sections, you are going to realize that with supervised machine learning, it is very easy to evaluate, using metrics like accuracy, RMSE, precision, and recall. For unsupervised learning, as the output is not known, it's not labeled, it's very hard for us to evaluate since no true labels exist. All right, so let's move to the next slide. At this point, I would like to know if I can be heard. Okay, Please, can you still hear me?
Yeah.
All right. Thank you very much. So at this point, we'll be talking about data pre-processing and manipulation. Now, with data pre-processing and manipulation, that is, if you want to build a machine learning algorithm, if you want to have a machine learning algorithm, you have to do certain things first, okay? Just like how if you want to analyze a data, you have to do an EDA. EDA simply means you have to do what you have to explore the data, okay? That's exploratory data analysis. You have to know the mean, the variance of the data. You have to know its distribution and then all that. When it comes to machine learning, too, we have a similar procedure that we have to go through. Okay, so one, we have to have a clean and well prepared data. Okay, you have to have a clean and well prepared data. If you have missing values in your data, you have to take care of them. If you have inconsistency in your data, you have to take care of them. If you if your data happens to, let's say, in a column it's supposed to be numbers, but there are some values in there which are names or something, you have to take care of them, and then you have to clean data as well. All right, and then two, as I said, okay, I was speaking about missing values already, and then so all right, I was speaking about it 1 and 2. All right, so this processing steps improve data quality, yes, helping models learn better patterns and produce more accurate and reliable results. So when we're able to clean our data and take care of all of inconsistency in the data, we are going to have a very good model that is going to give us good metrics. Okay. Now, if we want to build and evaluate models, this is what we have to do. The model development involves selecting algorithms appropriate for problem, training them on data set, and validating performance using metrics like accuracy, precision, and recall. What this simply means that we have already learned about the types of machine learning, which are supervised and unsupervised learning. So if you have a problem based on maybe customer segmentation, you know, you don't have to perform or you don't have to go and build a supervised machine learning. You have to go and build what? An unsupervised machine learning. Then you have to go through the different machine learning models that you have, because most of them have, not most of them, all of them have their individual assumptions and kind of data that they will accept. Okay, so we have to be aware of that. Then proper evaluation ensures model generalize well to unseen data, making them reliable for what production use. Now, let's talk about Python for data science. At this point, is there any question or is there any suggestion that you have for me at this point? If you can hear me too, please, I'd like to see some reactions from you to know that I can be heard and I'm being followed. Okay, Esmeralda, okay. She the only one following me? Okay, Denise, okay. All right, thank you very much, Esmeralda and Dennis. So we will continue from here. Now, why Python for data science? We've already spoken about its relevance or its versatility when it comes to the number of libraries it has that helps in simplifying machine learning algorithms. But I did a few research and I saw from databasetown.com when the census was done about the best programming language for data science, Python happens to be one, and then R follows. And then SQL also what follows. So that means that Python is being used mainly in the job market by our people that we are aspiring to be like, okay, data science and data analysts. Okay. So, as I've already mentioned, Python is a preferred language for data science and machine learning because it combines what? Power, flexibility, and ease of use. It offers a rich ecosystem of libraries for data loading, visualization, statistics, machine learning, and a lot. Okay, so we'll be looking at NumPy, Matplotlib, Pandas, and then Seaborn. But scikit-learn actually has most of the machine learning models there, but we won't be talking about that today. All right, and then also Python supports interactive and iterative work through tools like Terminal and Jupyter Notebooks. I'll be using the Jupyter Notebook today for you to see how it looks like, making it ideal for experimentation, rapid prototyping, and data-driven analysis. All right, so essential libraries that we'll be talking about today is talking about NumPy. Now, I've mentioned NumPy, Pandas, Matplotlib for a while now. I have to talk to you about what they actually means, okay? So NumPy is a library in Python that supports numerical operations. So if you want to add two numbers, although like base Python can help you, but sorry, although base Python can help you in that regards, we have NumPy to help us with numerical operations, to add two matrices, to do a lot of maybe sampling and all that. Okay. For pandas to helps us to handle data manipulation very, very well. If we want to import our data, if we want to change the variables of our data, if we want to do any manipulation of our data, we use pandas. Okay. Now for Matplotlib and Seaborn, they handle what? Visualization. Any graph that we want to create, whether it's a bar chart, a box and whisker plots, maps, histogram, any other kind of charts that we want to have, we can use what Matplotlib and then what Seaborn. For scikit-learn, as I said earlier, it provides the tools for building and validating what models, but we'll be talking about that today. All right, so from here, I'll be switching from my slides to my Jupyter Notebook, where I will be taking you through some. Okay, please, I'll have to stop sharing my screen right now, but I'll be back in a minute. For the time being, if you have any question, you can ask me, or you can also type your question in the chats, and me and Elvis will help to answer you. Thank you. Hello. Please, can I be heard?
Yes.
Okay. All right. Is there any questions so far about the introduction to Python? Hello. Is there any questions so far? Is there something that you'd like us to know? Hello. Are we okay? Can I continue?
Yes, you can continue.
All right. Thank you very much. All right. So we are now in my environment where I'll be using a Jupyter Notebook. Please, can you all see, or I should enlarge the fonts, or I should change the theme? Can we all see the way it is, please? Please, can we all see? Yes, you can see. All right.
Hello. Please,
Okay, so
there's
as
someone in the chat.
you said,
There's someone in the chat. Please check the chat. Somebody said you should go over.
I don't know. I'm sharing my screen. Elvis, please, can you help me to check what has been said in the chat, please? Hello, Elvis. Elvis, are you there?
Hi, I'll do that for you.
Oh, okay. Thank you. I'm actually sharing the window, not my entire screen, so I can't go back. I have to stop sharing before I can go back.
Yeah, the person in the chat said he can't see the screen, but then I can see.
The person said, okay, the person cannot see the screen.
Yes.
Probably to be a network, like the person's in the network. The person has to maybe drop the call and then join back to see whether it will work. Okay.
Yes.
All right. So please let's continue. So in this Jupyter notebook, as I said, we'll be talking about NumPy, we're talking about pandas, we'll be talking about matplotlib, and then
I can't hear anything. Why is it? Is it my network or?
Yeah, I also can't hear you.
Sorry guys, he just dropped off. I think his network is bad, so let's wait a little. Thank you.
Yeah, hello. Please, can you hear me?
Yes.
I'm sorry, my network failed me. All right, very, very sorry for that, please. And please, can you see my screen?
Yes, we can hear you and we can see your screen.
All right, thank you very much. So I was talking about NumPy fundamentals, and I was saying that NumPy is a foundation for numerical operations in Python. Okay, it provides efficient arrays and mathematical functions, making it ideal for data science tasks like statistics and what matrix operations. So we are going to look at how some of the basics, okay, some of the basics in NumPy, okay, things that we can actually do in NumPy, okay. So before that, I will have to import the libraries. As I said, we'll be using NumPy. Okay, we'll be using NumPy and pandas, matplotlib and Seaborn. So I'm going to import NumPy as NP. I don't want to be typing the whole NumPy, so I want to just be typing NP. So I'm going to import it as NP. I'm going to import pandas, okay, as PD. I'm also going to import matplotlib, okay, the one for visualization. I need only the pyplots as PLT, and I also be needing Seaborn, okay, as SNS. Now, the alias that I'm giving to the NumPy to the libraries are widely used, okay, which means that like most, not most, data scientists or analysts or anybody that use data that use Python and is importing these libraries use this alias. Okay, it's a very common practice. Okay. All right, so let me just do one thing that isn't really part of the work. I want my graphs that I'll be doing should have a white background, white grid. And I also want to set minutes. Okay. I also want to set, just do figure. This is for the graphs. Okay, because I'm using. All right. Setting that to 7.5. All right, so I'm going to run this to import the libraries. Okay, now for NumPy, we are going to look at an array. Okay, an array is just is a collection of elements. Okay, that's numbers, text, etc. And they are stored in a structured form, so you can easily access and then manipulate them. Unlike lists, okay, unlike lists in Python where a list can contain more than one data type. By data type, I mean we can have Boolean, we can have integers, we can have, what can we have again? We can have strings, we can have characters, all in what? In a single list. But for NumPy arrays, they must contain a single data type. Okay, so you'll be seeing that I'll be using only integers throughout this introduction course. All right, so I'm going to first create a one-dimensional NumPy array. So let's say I'm going to call it list D1, where I'm going to call the I'm going to call the library NP. I'm going to call array. Okay, let's how we create a one dimension. This is how we create a one dimension array in Python. So I'm going to just call the name of the list. And as we can see, we just have a one dimension array. And then this is similar to you saying that you've created a vector. Okay, those of you doing 39, you can say this, you just creating what? A vector. And we can also create a matrix which can have a 2-dimension, okay? That one, how are we going to do it? So we're going to have a name of the variable. So we're going to call it list underscore d2. We're going to have np.array again. Then we are going to create what? And look at how I'm creating it with the 2-dimension. You see that I have to open a very big square bracket before putting, yes, Momuni. Can I see your hands up, please? Do you have a question? You can.
Yes, please. Are we supposed to be doing what you are doing along? Like, are we supposed to be doing that? Are we supposed to be doing?
Yeah, if you can, I don't know. Obviously, you informed Nana Abena, were they informed to have their laptops as well?
Yes, please. In the congratulatory message, I informed you guys to get your laptop ready because this is our first session, which will be introduced to Python and machine learning. So, in the
Okay.
congratulatory message, that was indicated that.
Oh, okay. Okay. It seems like my friend Momuni did not get
Was
the
it,
info. Yes.
please, if sometimes you can pause and ask them if some of them have done it, so that they can also send a
Mm.
screenshot of what they have done into the chat box, so that you can see the progress that they are making with the teaching as well.
All right. All right. Thank you. Thank you
So,
very much. Okay. So that's being said, let me create the last array, which is a 3D array. Okay. Then I'll pause a little and wait for your submission as well. All right, so with the 3D array, we are starting with the same, like similar thing. We are giving the name to our array. Okay, so we are calling list underscore d3, and we are typing np to call the library. Okay, the library that we imported here, which is numpy. Okay, we are calling it np, so we are using np to call for it. Then we type our array again. Now for the 3D, this is how it's being created. You have to look at it very, very careful. So I'm going to have a bigger brackets here, okay? Bigger brackets. And inside that bigger bracket, I'm going to create another one again. And inside that one, I'm going to have my elements or my matrices, okay? Before that, I think I didn't show you the 2D. Okay, so let's see how the 2D is. I'm going to do print underscore D2 that we see how it is. So this is it. As you can see, this looks like a matrix, okay, and so it's a 2 by 3 matrix. Okay, so this is how the 2-dimensional array looks like. Now let's go ahead and then create the 3-dimension array. As you can see, the first, I open one bracket, that's for the big brackets, and I open another one before another one. So the last one is where I'm going to type in my elements, say 1, 2, 3. Then I'm going to create a second one. Okay, you can see how I'm doing it. That let's say 2, 3, 4, 6. Then please, I don't know if you can see that, but you could see that after creating the very big brackets here, I just went back and then typed in what I did with the 2-dimensional array. I don't know if you can see that. So you can see that with the 2-dimensional array, we have only 2 brackets. We have one big bracket, then we have the inner vectors. Okay. So what we have here is actually a 2-dimensional array inside a 3D. Okay. So I'm going to create the other elements too as well, similar to what I've already done. So What did I do wrong? Here we have 1, 2, 3. Okay, I missed one bracket here. All right. So at this point, I'll pause so that you share your work in the chat box to show that you are following. Okay. All right. So David, please you kindly help me check it. Okay. Let me see. Okay, someone said following by quite faster. Okay, I'm sorry for going fast. Please, can you go over again about the Python? Okay. All right. So what I'm saying is that for the Python arrays, we use NumPy. Okay, there's a library called NumPy. We use the NumPy to create those arrays. Okay, the first one I have here is actually what a vector. Okay, it's just one dimensional array, and this is how it's been done. I've shown that we have to type the name of the library, which is what NP. The actual name is what NumPy, but we give it an AKA, which is what an alias, which is what NP. So we have to type NP instead of NumPy. So NumPy.array, we bring a bracket, then we type the element in what? In a square bracket. Okay. In Python, it's called list. Okay, in a square bracket. For a two-dimensional array, we have to open a bigger bracket and then type our elements in square brackets, just like this. Okay. Then for a three-dimensional array, we also have to open a big bracket, then open another bracket to contain the two elements that we are going to type, and then another one to say this just two. I can do more than that. Okay. So please, can you share your work in the chat group if you are following, please? In the chat if you are following. You can send screenshots of it. Okay. All right. And then this is how the 3D list also looks like. So I'm going to let me. Right, so this is how the three-dimensional array also looks like. Is there any question up to now? Is there any question that you have? Hello, are we following? Yes, Mumuni, please you can talk.
Okay, so please, I wanted to ask, like, what can we use like this for, like an array in machine learning or data science? Like an
Okay,
example, yeah, practical example.
All right, as I've already mentioned, this is just an overview of what you will be doing. Okay, so this is just like how to use the tools to do what you will be doing. Okay,
Okay.
so yeah. So all right, so let me just give you maybe a practical example. Still on regression, as you know, for regression has to do with solely quantitative data. Okay, that's numerals. Talking about, I mean, a linear regression, not not the logistic regression. I mean, regression. We can actually input the values in these arrays, and then we can do some manipulations on them. Okay, but the actual work will be done in the subsequent weeks. Okay. Dennis, I think I saw your hand. Do you have any question?
Yes, please. Please, can you hear me?
Yeah, I can hear you, please.
Okay, so my question is, you see, with a two-dimensional array, we have, let me say, two square brackets.
Yeah.
So with a three-dimensional array, I can also see three square brackets. So is it because it's three-dimensional, so three square brackets, two-dimensional, so two square brackets? I want to understand the concept.
Yes. This how it's being created. So if maybe you have seen an algorithm like that, yeah. but this is how it's been done. It's three. Yes, for three-dimensional array is three, for two is two, and then for one is one. Have I
Okay,
answered
thank
your
you.
question, please?
Yes,
All
please.
right.
Yeah, thank you.
All right. So
Okay,
I'll
Moses.
move away from arrays. Yes.
Moses,
Yeah,
please.
I can hear you, David.
Someone in the chat box is saying that you should come down a bit because some of them they are beginners and they want to see the structure of the code.
Okay.
Yeah, so please, if you
So
can
this
stay
is
here for, if you can stay here for 30 seconds or 15 seconds for them to see the structure.
okay. Okay. All right. I think it's fairly enough. I can continue. All right. So the next thing is to learn how to generate random numbers. Okay. Or yes, random numbers in Python. Okay. And here I'll be talking about sampling. Okay. So I can have, maybe I want to have 20 numbers from maybe a set of numbers, say from 1 to 100. I want to sample 20 numbers, okay, randomly. How then do we do that in Python? So I'm going to first give a name to whatever that I'm going to do, which is what? Sampling 20 numbers from a set of numbers that is from 1 to 100, okay? So I'm going to we are still using NumPy. So I'm going to do np dot random. Okay, that's random dot rand int, which is I want integers. Okay, rand int, and then inside that we have some things that we have to know. Okay, so inside that we have to first specify the start. So it's from 1, and then we specify the end. That's what 100. Okay, then we have to specify the size. The size is how many elements or how many numbers we want to sample from 1 to 100. So I want to say 20. Okay, and after that, I'm going to print whatever that I have created right now, which is my sampling that I just did. All right, so you can see that these are numbers from 1 to 100, and they were gotten randomly. If you don't believe me, I can run it again. Instead, we're going to have different values anytime I run it. Can we see that? I'm going to have different values anytime I run it. But if you happen to be someone that, okay, you want to generate random numbers, but you don't want your random numbers to change after you have generated them, that means that you have to set a seed, okay? You have to set a seed. The seed is going to help you to maintain the random numbers that will come out when you run your code for the very first time, okay? So to do that, we are going to do np.random.seed. Now, setting a seed, you can write any number. Okay, so maybe my favorite number is 11. So I'm going to put 11 there. Now, if I run the code for the very first time, I'm going to get what? This random digit, which is 26, 64, 81. If I run the number again, if I run the code again, the digit I'm going to get or the sample I'm going to get is not going to change. As you can see, it's still going to maintain like that. If I run it several times, it's still going to what? Produce the same sample from me. Okay. Please, is there any question? Because I would like to move on to the next thing I have on the board.
Moses, please
Please,
let them send a screenshot and let us see if they are following.
Okay. So kindly send your work. Yes.
You were saying something before you wrote from the MP random note sheet. I didn't hear you. The line was breaking.
Okay. So I was saying that if I have created a sample, okay, I took a sample randomly from 1 to 100, okay, and then I run the code, I'm going to have my values, okay, I'm going to have the 20 elements from 1 to 100 randomly. But the problem is that anytime I run the code, anytime I run it, I have different sets of words, of numbers. Anytime, all the time. I get to me. So if maybe you want a situation where the first sample that you got should be the same anytime that you run the same code, okay? So for that one, we do np.random.seed, okay? And then this seed, you can type in any number that you like, okay? And I want 11, so I will type 11 in there. Now, when I run the code, I have 26, 64, 81, 92. As you can see, if I run the code again, I'm going to have the same what output. Okay, have I answered your question?
Yes. So the number in the bracket is, it doesn't mean anything. It's just the 11 you put in.
You said the number in the bracket has not what?
Yeah, that means I can put in number, then I'll still get the same answer.
Yes, any
Like I'll still
number,
get
so you
it.
can put in number.
Yeah. Okay, sure.
Yeah, any number.
Okay, thank you.
So
You're
Moses,
welcome.
you can check Moses.
Yeah.
Please, you can check the chat box. Some of them have sent their screenshots. I think they are on track.
Okay. Hey, somebody said I'm active. Okay. All right. Oh, the guy that sent the work, please don't use my number. You use yours. Okay. All right. Okay. All right. That's good. That's good. Thank you very much for following. All right. So, all right. So let's continue. Now, I'll be talking about basic operations. Okay. Basic operations in NumPy. So we're talking about how to do element-wise math and then aggregation, like finding the sum, the mean, the standard deviation, and all that. So assuming I'm not going to work with a 2x2 measure. I'm going to work with a vector. Okay, that's a one dimension, so it will be very easy for us to follow. So I'm going to copy my one dimension that I did here. Okay, I'm going to copy it and I'm going to bring it. So I'm going to call. Yes, I'm going to call it A. Okay, so I have my vector A, which is my one dimension A. I'm going to create a different one as well. Let's say 2, 6, 8, 9. All right. What if you want to do addition of vectors, matrices? You know, the dimensions have to be the same. Okay. So if I have A being a 1 by 4 vector, My B must also be of the same what shape. Okay. So we're going to have, so now we have these two one dimension. So assume I want to do addition, like I want to add them. Let's see how NumPy adds two vectors. Okay. So I'm going to call it addition. It's going to be A plus what? B. Okay. So let's see how it did the calculation. So we call addition. All right. So we can see that when we did A plus B, which is a vector, we did A plus B. With NumPy, it's add them element-wise, which means it took 1 plus 2 to be 3, 2 plus 6 to be 8, 4 plus 8 to be 12, 5 plus 9 to be what? To be 14. So you can see how additions are done in Python in terms of NumPy. I mean, in general, that's how it is. So let's do multiplication. I'm calling it MUTI. I'm going to do A times B. For times is the star, the one on the 8 on your keyboard. Okay, let's do that one too. Let's see how that one too is. So I'm going to print that one too. So we can see that for that one too in NumPy, it does it what element wise. So we have 1 times 2, we have 2, we have 2 times 6, we have 12, we have 4 times 8, we have 32, then we have 5 times 9, we have what? 45. Okay, if you want to do for subtraction to, it's going to be the same thing. Okay, so we're going to try that, then you send me your work as well. So we have subtraction, and I'm going to do A minus B. Okay, and I'm going to print it out. I'm going to print. So as we can see for that one, so we have 1 minus 2 is negative 1, 2 minus 6 is negative 4, 4 minus 8 is negative 4, and then 5 minus 9 is what? Negative 4. Okay. At this point, is there any question? And if you are done with it, so you can send it into the chat for us all to see. Hello. If you're working on it, you can send a reaction so that I know that you're working on it, so I can wait for you. Okay, I'd like to see some reactions from you if you are working on it, so as I can wait for you. Somebody said, yeah, you're not downloading the libraries. Come on. Sorry, let me see. Okay. All right. So at Mumuni, are you getting like, is your output come? Okay. I can see your output at down. Okay, I didn't see it first. All right. Okay. All right. So let me continue. Okay. Since most people are saying they're beginning, I don't talk about indexing and slicing again. So I'll move on to simple demonstrations. Okay, I'm going to talk about how to calculate some statistics on a sample data set. Okay. So let's create an array, okay, of scores. np.array. Let's create just a one dimension. So you can just enter any values that you like. Okay, don't copy mine. because mine is offered. This can be scores of students in your final exams. All right, so this is one that is scores of students in an exam. So here we are going to calculate some statistics, okay? So calculate statistics. It's supposed to be all right. So to calculate some statistics, let's say we want to find the mean, want to find the median of the scores, want to find the maximum of the scores, want to find the minimum, the variance, okay? The first thing that we're going to find here is the mean. So mean underscore score. We're also going to use np dot mean. Then we will input in the scores. Okay. To find the mean, okay, so we have like the scores of students in an exam, and then these are the scores. For you to find the mean, you have to do np dot mean of the scores. Let's see how it is. So print mean underscore score. So we have the mean of their scores is what 65.28, let's say 29. Okay. If we want to find the median, okay, so let's call it median underscore score. We're going to have np dot median. Okay, then we put in the scores. Let's print that one too and see how it is. The median underscore score. The median is what 65. Okay. So in similar context, if you want to if you want to find the maximum, the minimum, and then the variance, all you have to do is just the same thing, but where you see mean, median, you put what? Max, mean, and then var. So let's create that one too as well. So the maximum cost is np dot max. Okay, then we put our scores in there. Let's print that as well. Max underscore. All right, so the maximum score is 98. If you check, you can see that the 98 is the highest score in the array or in the scores. Similar context, you can do minimum underscore score is equal to np dot min. Then you have what? Scores. So we can check the minimum too. We can print minimum scores, and we have what? 19. Okay. So this is an example. This is how you can find some statistics, okay, from an array. At this point, is there any question? And if you are doing it to us, so you can send us a screenshot from. You can send us a screenshot. Yes, Mumini. Okay, I thought your hand was up.
Yes, please. I wanted to ask, you can do this with like Python without importing NumPy libraries, right?
Yes.
Like
You
by
can do this.
importing the by importing the statistics module, or like for something like this, can you do that?
Something like what?
Like I know that when I want to calculate mean of probably a list or something, or maybe a tuple, or like I want to
Okay.
calculate mean, I'll import like the statistics model. Can't you? Why? I'm asking if you can do that without importing the NumPy library, like for an array too.
Okay. Oh, You want to ask if you can calculate the mean of
Yeah, like
let's
of
say a
not.
vector or anything without you calling for the NumPy array library. Is
Yes,
that what you're saying? All right.
yes,
So let
please.
me tell you the main reason why we are using the NumPy library is because it is very, very fast, and then
Okay,
it's helped us to handle. You see, what we are doing here is very, very small. We have like 5 elements or 6 elements, but we can do much more by let's say we can have much more data, okay? But the NumPy is very, very fast and very, very efficient in handling these statistics and then these calculations, okay? So that's why it's like you have to be told and you have to learn how to use it to be used to it before you have like a bigger data that you'll be using the base R in doing that you find it time consuming, okay?
okay. All right.
Uh-huh.
Thank you.
So it's not necessarily for you to call the NumPy array, but it's a good practice for you to call it.
All right, thanks.
All right. So can I continue? I'd like to move from the NumPy array and then go to pandas, then finally end at the visualization. Are we following? Are you following? Are you done with the statistics? David, are you there? Hello, David. Okay. All right. So let's continue with the pandas. Okay. Now for the pandas, it's a great tool for handling tabular data. Okay. It introduces data frames. Data frames are more like what you see in your Excel sheets. You have rows and then you have columns. And then all the columns are your variables. Okay. So the columns can be maybe the age of student, their name, um, course titles, GPAs, I get so the columns are the variables, and then you're going to have the rows. The rows are the observations. So maybe what one row can be the observation of one person. Okay. So if the column is a name, the row is going to be the name of that person's age, that person's GPA, that person's course title, and all that. So we are going to see a very simple way to import data. But specifically, we are going to import a CSV, a common separated value file into Python. Okay. I already went to Zindi and I took one of their data. Okay. So we are going to import it. I'm going to call my data df. Okay. And I'm going to call the pandas. Mind you, I imported the pandas and I gave it an alias. What? PD. Okay. So I'm going to use PD here. I'm going to do PD dot read underscore CSV. Okay. Read underscore CSV. And I'm going to type the name of the file. Mind you, I'm able to do this because the folder in which the file is in is the same folder in which my data is in. Okay, so you can see here that I have my data here. Okay, this is my data. My data is in the same what folder as my Python code. Okay, so this is the data, and they are all in the same what folder. For this reason, I can easily type the name of what's of the file. I can easily type the name of the file into. I'm going to put it into commas. How do you call it? Is it inverted commas? I'm going to put them into that, and I'm going to run it. So I have the name of the file being agribora underscore mate underscore prices.csv. Okay. So once I run it, I can look at it. Let's look at the data. We can just type df or we can type print. Okay. Let me just do df. And here we have, so we can see that we have the data. Okay. let me just do a quick correction here, okay? Let me rename the first column. It's actually supposed to be cities and not countries. So let me just do that quickly. This isn't part of like the country. Like I want to call it cities. All right. Let me
Hello, sir.
yeah, hello.
Yeah. Sir, if you are to follow what you are doing, how how do we have
Yeah,
access to the data set?
exactly. I should have sent the data set first to you. Let me see if I can get the data from Python for you. Okay. Give me a minute. Give me a minute. I'm coming.
Okay.
All right. So let me use a built-in data. Okay. Let me use a built-in data. So I'm going to, let's say I know of the Titanic data. So let me take that so you can always see what I'm doing. Okay. So I'm taking that data from the Seaborn. Okay. The Seaborn, when we import Seaborn, we call it what SNS. Okay. So we're going to load that data set. There's a data set in Seaborn called Titanic. So let's just have that Titanic. Okay. All right. So this way you can all follow me. Okay. There's this data in Python called Titanic, and it's in the Seaborn library. Okay. So we can all go there and then we can all write this code to get that data. Okay. Hello. Please, are you following? Have you gotten it?
Yeah. I've gotten one.
Okay. All right. So I was supposed to show how to import a data. Okay. When you have the data on your machine, which I did first, but so let me still do it again, but I would let me do pd.read underscore csv, then you type the name of the file, given that the file is in the same folder as your Python, okay, your Python file as well. All right, so having the data set called Titanic, we can do certain manipulations on it, okay? So the first thing that we can do here is to display the rows already. Already this, just by typing df print print df, we get to see the entire data, okay? But assuming we want to see only maybe the first 5 rows, the last 5 rows, we want to see the shape. What's the dimension? Is it 2 by 1,000 or 1,000 by 1,000? We want to see the shape, okay? We can do certain things here as well. So we are going to use head. Okay, so the data frame that we got, we name it was df. Okay, so we're going to do df dot head, and then just df dot head alone is going to give us the first 5 rows of our data. I hope you can see that. The first 5 rows of our data. And similarly, if you want to find the tail, which is the end, the last rows, you can just do df tail. And that also gives us what the last what rows. As you can see, is from 890, 889, 888, 887, 886. So these are the last rows of our data. Now, if we want to find the dimension, as I said earlier, it's a tabular data. So we want to find the number of rows and the number of columns. The number of rows, to do that, we're going to do df.shape. Okay, df.shape, and that is supposed to, oh, sorry. So df.shape, you don't have to bring the brackets. So that means that we have 891 rows and we have 15 what columns. Okay.
I can't hear anything now. Am I the only one?
Yeah, hello. I think Moses' network dropped. He'll join very soon, okay? Let's give some few minutes for him to join.
Yeah, hello.
Yeah,
Hello. Please, sorry, my network just keep on
oh, don't,
going
don't worry
off.
about it.
Is that?
Don't worry at all. You can share your screen again.
All right, thank you very much. Okay, so I think I was talking about Okay, I was here and I was talking about how to how to find the shape, okay, of our data, that's how to find the dimension, the number of rows, the number of columns, how to find the dimension. And I said it was a df.shape, okay. That's also going to help us to find the dimension, okay, of our data. All right, please, if you are following, you can be sending screenshots of your work into the chat. We will be checking it from time to time, okay. Time is fast spent, and I like to do. All right. So if you want an information, okay, on your data, as you want to see some summary statistics or just an information on your data, we have to do df.info. Okay, we do df.info, and that's come on. I have to run the whole thing again. I'm coming. Sorry, I have to run my code again. Please, a minute. Okay. All right. So if I want information on my data, I'm going to do it df.info. And df.info is going to give me an overview, an understanding of my data. It tells me that with a column called survive, the values in there are all what integers. There's another one called p class in the data. They are all what integers. For sex, they are objects. For age, they are floats, which means that I don't know whether there's decimals in there. For alive, and then for alone, we have Boolean, that's true or false. Okay, so that's to get an information on your data. I'm supposed to go through with you to how to filter and select data, but I mean, time is fast spent, so I'll move on to the visualization where I'll show you how to um how to I mean come out with some visualization for your data. Okay, so quickly we are going to create our artificial data. Okay, I'm going to create a sales by product category. Okay, I'm going to have a category. I'm going to create sales data attached to that. Okay, so let's say my categories, I'm calling them, I have category A, I have category B, I have category C. As you can see, the inverted commas, I'm using only one. If you want to use only one, you use one throughout. If you want to use the double inverted commas, you use the double inverted commas throughout. Okay. So I'm using one throughout. Category D. All right. So the sales, I can just enter any sales value. Okay, any sales value at all. As you can see, I'm not writing in the base Python, so I'm having lists. So the brackets that you see here, one here, are all what lists. Okay, it's not like the NumPy array where I have np.array. This is just a normal list. Okay, so I'm going to have some values. Let's say I'm having 2,000, 4,000, 55,000, and then let's say 40,000. Okay, so these are. Let me do this. So this is just a sample data that we have here. Okay, so we can actually create a bar plot using this data. Okay, how then do we create it? So let's call our plot bar. Okay, so we are going to call the PLT. The PLT here is the matplotlib. Okay, it's from what the matplotlib. As you can see, we call the matplotlib library and then we give it an alias. Okay, and the alias was what? Was PLT. So that's where I'm coming from. Then we call PLT dot bar. There's a function in Matplotlib called bar. Then we open the brackets. Now the first thing that we have to put is our X, the X axis. Okay, so the X axis is going to be my categories. Okay, it's going to be my categories. Then the Y axis, okay, basically is going to be what? It's going to be my sales. Okay, so let me see if I can run this. Okay. All right. So PLT bar, I have my sales. Don't know if there's a mistake with my sales. Let me check. I mean, all right. So the first element, the first place is supposed to be our X axis, which is what the categories, and then the Y is supposed to be what the Y the sales. Okay, so this just this simple thing here can give you what a bar chart. Okay, so we can further go ahead and then customize it, give it a title, name the X axis, name the Y axis, and all that. So let's say I want to give I say color, I can say color, then the list, I can list my color. Let's see, I have blue, then I have red. There are four, so let me add one. Let's say or just by just doing this, I give every element what its own color. Can go ahead from here and give it title. If you said that's PLT dot title, okay, like that, give that opportunity. Hey, to call it sales by categories. Right. Let me see. So I feel like I'm not alone in the chat. Following, can I see some reactions from you? Please let me see some reactions from you. If you are still in the chat, please. If you are still on it. Somebody said I can't hear anything. Emmanuel,
Yeah,
please, can you hear me now?
it seems your sound is behind, like it's far.
Just a minute and tell me. A great work submission on Jerry. And so,
I can't hear you.
okay. So I can see that I'm being followed. Right, so now we are on the organization. So this is how to create a simple that's okay. Right. So I can still use data to create this we can add more things. As I said, but you can add the X label and the Y label. It's just a simple way of creating a website that you can learn more about it. Since you have literally there's something else that's bar charts. That's more. So we're going to create pie charts now. We are using the same data, same sales by category.
Hello, Moses. Can you hear me? Hello. It seems your voice or your volume, and we can't hear you well. Can you get closer to your computer and speak for us to see? I think the volume is very low. We can't hear you. Yeah, hello everyone. Moses' network dropped. His mic issues, so he joined back again.
Yeah, hello. Please, can I be heard?
Yeah, Moses, you can be here. You can share now. You can share.
Yeah. My network isn't doing justice to me today. So I'll let us we'll go through the pie charts. We'll go to the pie chart, how to create the pie charts, And I think I'll end it here, okay? But I'll share the codes with David, and then he is going to share it with you, okay? All right, so we are still using the same data that we got, which is we generated, which is the categories and then what, and then the sales, okay? We're going to create a pie chart. We are going to use the same PLT, that's from the matplotlib library. We're going to do plt.py, and then we are going to type in the values, which is the sales. Let me see if I type. Let me see whether I can get. Okay, I can get something. All right, this isn't that nice, but we can customize this. So you just do plt.py, then putting in the values, which is sales. You can get what a pie chart. Then from here, we are going to customize it and make it look good. Okay. The plt.py. So we are going to label it. Okay. Let's say we want to label like the way pie chart is. It has to have some labels. Okay.
Please, I can't see your screen.
You can't see. Oh, okay. Sorry. Sorry, my network was messing up, so I'm talking without sharing the screen. Sorry.
Okay.
All right. Yeah. So please, can you see now?
Yes, please. Yes, please.
All right. So I was saying that with our same data, if we want to create a pie chart, we are just going to do plt.py, and then we put in the values that I want to use to create the pie chart. Okay. And the values here are 20,000. Let me change this to 40,000. 55,000 and then 40,000. Let me change this to 60,000. All right. So by just doing this, we can get what a pie chart, as you can see, a basic one. Okay, but this isn't nice, so we have to customize it. Okay, so I'm saying I'm coming to label them. Okay, I'm going to label them. So I'm going to do labels that's still inside the pie. So labels, I'm going to call them categories. As you can see, I've already named my categories. So I have category A, B, C, and then D. By me writing labels is equal to category, it's going to pick A and then attach it to 20,000, B to 40,000 as follows. Okay, so that's it. So that we have now labeled what our data, our pie. Okay, now we can go ahead to further customize it by giving it a title, by giving it a legend, by even changing the colors that we are seeing here. We can do a lot of things with it, but time is fast spent, so I'll go on to the next one and then I will end the section. Okay. I'll share the codes with David and then he's going to give it to you. Okay. For that one, you are going to have the full customization of all the graphs and then you can learn from there. All right. So with the last graph, we are going to talk about histogram. Okay. So I'm going to still get some scores. I'm going to get some random values. Okay. But here I'm going to sample from a normal distribution. Some of you have been introduced to that. Sample from a normal distribution. And this is how it's done. So we are still doing NP. We call the NumPy library again. So it's going to be np.random. Then I call the distribution. Okay. So distribution here is called what? Normal. That's normal distribution. And some of you might not know this, but normal distribution has some parameters. Okay. It has its mean and then variance. Okay. So let me just type a mean of 75. Variance of 15, and then I want 200. You might not know this, but it doesn't really matter. So the scores just have to have some values. So let's look at the values that we have. So these are the values that we have. We have this value from what? A normal distribution, 200 of them. Okay. We're going to use this data to plot a histogram. Okay, do that is simply plt.hist. Okay, plt.hist. Then you bring in the scores. Okay, so a simple plt.hist scores can get us what, a nice histogram like this, and we can go ahead and then customize it. Okay, so we can give it a title, say plt.title. Okay, so let's just call it distribution of force. Okay, that's it. And we can also name the x-axis with plt.x label. So let me just call it scores. And we can also name the y-axis as well. Okay, so plt.y label, and we are going to call it frequency. Okay, so we can actually do a lot of things. We can actually do a lot of customization. Okay, so since you have been introduced to how it's been done, like this is a simple way of doing it, so you can research more, learn more about it. And if you are new to Python, I would advise you that you start learning the basics of Python before you move on to the libraries as well. So at this point, I would like to bring the presentation to an end, and then I'll open I'll open up for questions. Okay, so if you have any questions based on the field that we have been able to capture today, from introduction to machine learning down to Python for data science basics. If Elvis or David or Nana Abena is here, you can take over the session. Thank you.
Please, I have a question.
Okay.
Please, the score is equal to np.random. The parameters inside is the mean, variance, and what? The third one I don't.
N, the number of
Oh,
samples that we want.
oh, okay, thank you.
Yeah, you're welcome. Is there any other question? My network didn't allow me to do much, so at least the little that I've been able to do, I hope we've all learned something from it, and we are all going to build upon the knowledge. And then, I mean, we have to do the most work. We have to search and then get an understanding of what has been done. Yes, Momuni.
Please, at the point where what is it? Excuse me, please, I'm coming now. The point where
Okay.
we did some data thing. The one you said you need to have the file in your folder or something.
Yes,
That
yes,
part,
yes.
the CSV something. We use some Titanic
Yes.
data.
Yes.
Please, can you go over that part again, like quick, but go over it quick for me.
All right. So I was saying that for us to be able to import data, okay, we have to. Okay, I'm using the pandas. So assume I'm calling the new data df1. We have to do pd.read. If the file is a CSV file, we're going to do read underscore what? CSV. Okay. Then inside here, we have to type the file location. Okay. So if the file is maybe on your desktop, you have to copy the file location, and then you come and put in. You can put this what inside. Okay. What I did was that I have the data in the same folder as my Python script or my Python notebook. Okay. So all I have to do is that I just have to type the name of the data. Okay. And here the name of the data is agribora underscore maize underscore prices.csv. Okay. If I type that in here and I run it, I'm going to have the data. Okay. All right. Some of us might not be having the data, so I decided, okay, let's import a built-in data in Python. Okay, so in the library called Seaborn, okay, Seaborn, we have a data called what? Titanic. So I say df should be equal to SNS, which is the library name, and that dot load data set. Okay, and the name of the data set is what? Titanic. So I have to type Titanic in there. Okay, Mumini, did you follow?
Yes, please. I'm following.
When I type in there and then I run it, I'm going to have what? The data being loaded, but it's now in what? The variable called what? df. So I have to come and view it. Okay, so I just type df and I run it. So I have the data. And
Oh,
data
okay.
in that data set, we have survived, we have P class. So this is the data that is showing here. But there are so
Right.
many. There are so many. I think there's one called Iris. I don't know if that's also in it's in that one. Yes, Iris. It's also in SNS. Okay, so that one we have the separate length, separate weight. So you can do this to get the data in R in Python itself. Sorry for mentioning R. All right. I've answered your question, Mumini.
Yes, please. Thank you.
You're welcome. You're welcome. Is there any other question? Elvis, are you there?
Yeah, hello.
Nana Bina. Yeah. Elvis, I think there's no other questions, so I think we will have to end here, and maybe some other time we can continue from where I ended.
So thank you very much for this opportunity and for sharing
You're
great
welcome.
insights with us. Please let's thank
You're welcome.
Moses. Okay, please let's share some images thanking him. He has done so well today, and we are very pleased to have him. So kindly take note that the session has been recorded, and during the week we'll share it with others. This is the first week of our 6 weeks Machine Learning Fundamentals Bootcamp in partnership with the Ugass Data Science Club and then the Zindi community or Zindi. So today's session is the first one. During the week, the participants who are accepted into the bootcamp, you get an exercise to do. If you couldn't get accepted, don't worry, you can still join all our individual sessions, right? And we'll share updates with you too, the recordings and all the resources the participants will have. You have that also. During the week, we'll share a flyer for the next session, which should come off next week, Saturday rather, right? This week we should have had it yesterday, but we had some 1 or 2 challenges, but things are streamlined now. So next week, Saturday at 8 p.m., we have our next session. Also, kindly take note that a Google form has been shared to our chat, right? We want to help our research lead, who is part of the course, Jim, to help us in our reports and document our progress. And also share with the team how we can improve your performances or improve the bootcamp experience. We kindly take a few minutes. I told him not to make the form long. So with 2 minutes, the questions are not even all compulsory. Take 2 minutes of your time to fill the form and then tell us your feedback. Did you like today's session? What do you think we should do better? And then finally, we sincerely apologize for 1 or 2 network glitches, but next time we'll do well to do better. Finally, for staying with us from the beginning of the session to this time, and we might say we are forever grateful, and we thank you all for joining. Next week, invite another person to join. We'll make the recording available, so when they even join in the second week, they can still have it. Thank you all very much. I see there's a hand raised. Jerry, you can speak.
Yeah, so my question is I haven't received any email on acceptance, so I don't know whether I've been denied or I still.
All right. All right. So kindly take notes by tomorrow, God willing, close of day tomorrow. Those who we are still not done, you get to hear the feedback as respect to the status of your application to partake in the bootcamp. You get your feedback on that. Thank you very much, Jerry. So thank you all for joining today's session. We'll meet again same time next week, Saturday rather. Bye.